Hi folks, I'm Bill Vales. On this Fun with Science, we are featuring the Littleton Robotics Team 6328, Mechanical Advantage. We have two shows that cover the entire process of building a robot. We start from the design of the robot to fabricating parts, assembly, testing, and programming. We also cover the competition between robotic teams, including the scouting of the competition and the strategy employed on game day. This first robotics show introduces you to the Littleton Robotics Team 6328 Mechanical Advantage and the process of designing, fabricating parts, and building the robot. Sit back and take a look at the accomplishments of some of Littleton's young adults in demonstrating their STEM acumen as well as their teamwork and competitive skills. Enjoy the show. Hi, Bill Vales here, and I'm here with Deana Clark. How are you?
I'm good, Bill. How are you?
I'm doing good. This is our third year, I think, with 6328.
Yes, it is.
Yeah, the Littleton Mechanical Advantage. I should say this correctly. 6328 Mechanical Advantage, Littleton, Mass. And you have another robot extravaganza going on?
Yes, we do. So the game this year is called Destination Deep Space. So it's this kind of cool space-themed game. And there's basically 3 different tasks you have to do in the game. You have to score these balls that are called cargo into various points on the field, place what they call hatches on other points in the field, and then at the end you can climb up into this large step for bonus points. So it's a pretty cool game this year.
Welcome to the 2019 First Row Robotics Competition and this year's game, Destination Deep Space, presented by the Boeing Company. 2 alliances of deep space travelers race to place hatch panels on their rockets and cargo ship, load valuable cargo for transport off the planet, and return to the safety of their habitat, all before the next sandstorm sweeps through. Alliances earn points for exiting the habitat, securing hatch panels, and any cargo that's properly stored. The alliance that earns the most points wins the match.
Just to back up a little bit for our audience, you build a robot, correct?
Yes, we do.
Yeah.
So basically what happens is we get a game animation and a rule book in the beginning of January.
Okay.
And then we basically get 6.5 weeks to build a robot to play that game from scratch.
6.5 weeks. And how large is your staff?
Yeah, so we have 39 students this year, which is our biggest team ever.
39, wow.
And about 10 mentors. And lots of parents helping as well.
Yeah.
So it's a big group of kids this year. We've got a lot involved.
Yeah. And what are the age group of the kids?
From 8th to 12th grade, but our team is definitely heavier on the 8th and 9th grader side. Because another video you guys did with us was with our first LEGO League teams.
Yes,
a lot of those kids have
that.
graduated from the LEGO League to come up to the first robotics competition. So our teams are pretty young, which is great because then they get 5 years in the program and they have a lot of time to learn and grow.
Okay. Deana, what do we have here?
So Bill, this is our 2019 robot. It's bagged right now because basically what happens at the end of the 6.5 weeks is they say that's the cutoff and you have to put it in this bag and you can't work on it outside of competitions or designated out of bag times. So that's what we have in here. The robot competed just 2 weekends ago, and then we had to bag it up again. So yeah, this is our newest creation.
I see. And I remember last year you had your robot in a bag and you can't touch it at all. So the rules of the competition are fairly stringent.
Yeah, they definitely are. They just want to make it kind of fair across the board to all the teams. But actually, next year, they decided to get rid of the whole bagging concept. So if you come back next year, this robot will not be in a bag, and we'll probably still be all hands-on working on it.
Really?
So they changed the format for next year. So this is the last year of the bag.
Okay, so that's quite a change, because I would think after you compete once, you look at it and you say, oh, geez, I wish I put a gadget in here. I wish I programmed it a little differently there.
Exactly. And I know that we had a lot of those feelings after our first event, like, oh, we should have done this and that. And I'm just imagining where we would be if we didn't have to put this in a bag. So they're definitely, it's going to be a whole new way to play the game,
Yeah.
whole new way to approach it. But I think it's a positive change, and I'm really excited about it.
Okay, great. And I see here there's a whole bunch of different components here. We'll probably see them on some unbagged components and robots. But you have gears and pulleys and a lot of metal.
Yes.
Yeah. Are all these pieces machined?
Yeah,
by
so some of our sponsors like Bose water jet on these plates for us here. So you see all these triangles in here. That's called IsoGrid. It's a great way to lighten aluminum pieces while retaining most of the strength
I see.
of the original piece. So that was water jet, but all these different crossbars up here and some of the internals were made in-house by our student members, either on our manual mill, our manual lathe, our own in-house CNC router, which is really cool.
It is a cool machine, and we'll show that later. We have to point out your sponsors here.
Yes,
Yep.
of course.
Yep.
We have some really awesome sponsors, Zoll Medical, BAE Systems, Patriot Beverages, who's our team's top sponsor. They give us this building to work in, which is awesome. Viasat, Bose, Workers Credit Union, and then Boxborough Regency are some of our top sponsors this year.
That's great. Is there any significance to the fact that these cutouts are triangles and not circles or squares?
Yeah, so we do triangles because that is the strongest shape, essentially. So we want these metal pieces to stay as strong as possible, but also be light because there's a weight limit, 125 pounds. So we do kind of like a truss, like obviously trusses are really strong. That's what they make bridges and stuff out of. So that's why we do the triangular lightning pattern.
They're all triangles. That's great. Okay, well, let's walk around.
Sounds good.
Hi, I'm here with Sara and Madi. Sara and Madi. Right, let me get that in the right order. And how long have you folks been members of the 6328 project?
This is my second year, and this is Sarah's first year. I'm a freshman, and she's an 8th grader.
I see. And how do you like it, Madi?
I like it a lot.
Yeah, apparently to come back the second year.
Yeah, definitely.
Yeah.
And definitely my sophomore, junior, senior years as well.
Yeah, great. And Sara, how do you like it?
It's definitely been a great experience, and I will definitely come back next year.
That's wonderful. That's wonderful. Okay, Madi, can you explain what we have going on here, what this machine is and how you use it?
Sure. So this is our CNC router. This one's 8x4, so it's relatively small, but it cuts parts right now. We have MDF, which is a bit like cardboard or wood on here. But it can also cut Lexan. This is Lexan right here. It's a type of plastic, as well as aluminum.
Okay, so this piece here that you're holding, Sara, those might be like an arm for the robot?
Yeah,
or something like that?
Yeah.
But that's the idea. So this starts with perhaps a rectangular piece of, is this Lexan?
Yeah.
Okay, and then you cut it out.
Yeah, exactly. And the nice thing about the CNC router is the fact that it's programmable. So we can take a CAD model that we make on a computer, and we can essentially translate it so that our router right here cuts it for us, and we don't have to make it manually.
Okay, so there's some programming involved that you use some sort of CAD system?
Yeah, so we use SolidWorks to design and CAD it, and then we use a program called Fusion to translate it from CAD language to router language, essentially.
Okay, and that's all part of the CAD system?
Yes.
Those tools. Okay, and this is CNC, which stands for?
I'm not actually sure. I've been told this before, but I'm not sure.
Okay. I'm not sure either. Computer numerically controlled? I don't know, I'm making that up. We'll go with that, okay. Okay, so you said that this is a 4x8. You mentioned some numbers.
Yeah, this is 4 foot by 8 foot. What? 2 by 4. That makes a lot more sense. Okay.
Okay.
That one's 4 by 8. Ah, there we go.
There we
go.
Okay. Great. We got that done. Now I can see here there's a work in progress going on here.
Yeah. So this is this was a suction cup that we're making. We're currently prototyping different suction cups to attach to this big disc of plastic. Essentially, it's a game piece.
Okay.
And yeah, that was one of our prototypes.
Okay. So you write the program for these shapes.
Yes.
Okay. And then you take the program, you download it or upload it to this system.
Yeah, it's all cloud-based.
Oh, okay. How foolish of me. Okay. And then that router moves according to those instructions.
Yes.
And cuts that out.
Yes.
Wow. And you can use different types of materials on here?
Yeah,
Okay. So you must have to change your router bits?
we do.
Okay. What's the most important safety thing you have to do when you're in the shop here?
I'd say it's a toss-up between wear your safety glasses, keep long things, hair tied down, and make sure everything's screwed on correctly and cleared of the router area.
Okay. That's the same answer I got last year, so that's very good. Great. Okay. Let's go on to something else. Okay, we've moved over not that far from the CNC machines to two large machines. And I'm here with Hunter now and Sara still. Okay. Not Sara still, but still with Sara. Okay. Hunter, what is this machine?
This is a lathe, and we use it for drilling holes and tapping into stuff.
Okay. And what sorts of materials can you fashion with this lathe?
We use it on metal and plastic.
You can use plastic on that.
Yeah.
Yeah.
Only for tapping though, because
Yeah.
if you spin it, it'll get too hot.
Okay. Now, what do you mean by tapping?
So tapping is so that way screws can screw into it, and we put it in there, and instead of having the machine turn it, in order to get a perfectly straight tap, we put the tap into here and the piece into there, and we manually turn it very slowly so the taps don't get messed up.
I see. And this has the benefit, I would think, that it stays perfectly centered.
Yeah, we put the piece right in there, and we can make sure that it's perfectly parallel, so we get a perfectly straight piece.
Wow. Do both you folks operate this?
I do not. I have before, but
You have.
yeah, but not during robot season.
Okay. Okay. So, were you operating it to practice?
Yeah, it's for practice.
Okay. Okay. How long have you been involved with 6328?
This is my first year.
Your first year. How do you like it?
I like it. I'll
Yeah.
definitely do it next
Yeah.
year.
Great. And Sara, do you operate this?
Yeah, I do.
Yeah. You like an old pro on it?
Yeah, I know how to make the basic pieces. I know the basics.
Yeah. Great. Okay. We're going to step over to the Bridgeport milling machine. I guess we'll just step over. Okay. So now we're over at another large machine. And I do know what this machine is because my brother has one in his basement. But you tell me what it is.
It's a Bridgeport Mill.
Bridgeport milling machine. And this weighs a ton. Yeah. Is it a machine that you've used?
Yeah, I've used this one probably more than the lathe.
Okay. And what do you use this for?
We use it for cutting down pieces and cutting them to size.
Okay. And is it used for anything else like drilling? Or?
Yeah, we can also drill holes.
Yep.
And smooth out pieces too.
Okay. Okay. Now, you must be able to obtain a high degree of accuracy with the cuts that you make on this, can't you? Yeah. Do you know what level of precision you can obtain on this?
Probably pretty close to perfect. We have a little machine over here
Yeah.
that we can zero and make sure we're getting the measurements exactly right down to the thousandth of an inch.
Yeah.
Thousandths of an inch. Okay. That's pretty accurate. Okay. Great. And you know, building the things you are, you need that level of precision, I would think, to get things that run properly. So that's great. Okay, Sara, we have what appears to be a full-blown machine shop here. Can you just quickly step us through what some of these tools are that are here?
Yeah, right here we have some table saws, which
Okay.
we can use to cut wood. We have some smaller drills back here, and we have a bandsaw so we can get thinner pieces.
Okay. It's interesting that you mentioned using wood. Why would you use wood? You spoke over there at the CNC machine that you were using sort of like a particle board over there, and then you talked about using metal and plastic. Why would you use wood?
Well, on the real robot, we use mostly metal and strong plastics, but when we're prototyping and building the field elements, we use wood.
Okay. So prototyping is part of this whole process.
Right, so for about the first week or week and a half, we spend most of the time building prototypes so we get a better feel for what to do when we finally get to build the real robot.
Okay. And it also doesn't hurt as much financially if you have to throw it out.
Right.
Right. Okay. Prototyping. So that's a very valuable lesson in any type of engineering endeavor. That, you know, figuring out how you can prototype your ideas to get a sense if they work or not.
Yeah, we started off with many, many different ideas for how to do the different field elements, and we narrowed it down to our top choices.
Yeah. So when you say field elements, what do you mean by that term?
Well, there are different places where you can place the game pieces, the balls and the plastic discs, and those are the field elements, and there are different levels and different places where you can put the balls and the discs on the field
I
elements.
see. Okay, great. Okay, Deana, we're looking at a whole collection of, well, actually, we're looking at, well, why don't you tell me what we're looking at here?
So this is the remnants of our 2017 robots. This was our original robot, BotBot, that we made our rookie season. BotBot was the name. It kind of it started with a joke and it just really stuck, and so we went with it. So BotBot took us all the way to the World Championship our first season, which was incredible. And we had a really good season with this robot. We did a lot of demos with it, community outreach after the season, but robots only live so long. So, and there's a lot of expensive parts on this robot that we needed to salvage to use on new robots. So that's why BotBot's kind of in pieces.
I see.
Right now, because a lot of electronics and some of the metal parts we repurposed to put on our 2019 robot.
Well, that's really great that you can, you know, make use of old parts. And it looks like a lot of these components came out of your fabrication room.
Yes.
You know, your milling machine and lathe and...
Yeah, so these side pieces were water jet by iRobot in 2017, another one of our sponsors. But then pretty much all the other pieces you see, the whole superstructure, were created on... That year we didn't have a CNC mill, so all the other parts were created on a manual mill. Which was pretty impressive for that year, to be able to, first-year students, to make all these robot parts on a manual mill with no prior experience. It was really cool to see.
Yeah. Is that the iRobot that's on Route 3?
Yes.
Down, okay. And they do the water jetting in their facility?
Yeah, so we basically design the parts in CAD, and then we send them the file, and then they can cut it out with a water jet, which is pretty cool.
But you just need to put it up on the cloud, as I was told.
Yes,
in the other
you
room.
just put it up on the cloud,
Right,
yeah.
right. Now, have you ever seen the water jet process?
I have. It's pretty cool. It just basically looks like a really crazy water gun with sand in it. And obviously it's at a really crazy pressure, right? To be able to cut holes into metal. But it's pretty cool to watch.
Yeah, I bet. How long does it take to, say, do a hole, well, like this?
Probably a hole like that's probably a couple of minutes. The whole plate, I think, probably took like 3 hours or so. And it wasn't just one plate. Like, we lined a bunch up on like a 4x4 sheet of aluminum, as many parts as we could fit. And it was, a few hours to get it all cut out, which is incredible.
Okay. Okay, Bot.
You lived a good life.
What was 2018?
2018 was called First Power Up, and it
Power
was a retro video game theme.
Okay.
And that robot was named Revenge of Bot. We kept with the theme.
Okay.
And that robot's in the other room.
Okay. And this year's name?
Is Bot Begins.
Bot
We're
Bot
sticking
Begins.
with it.
Okay. Okay, great. Let's continue on. Okay, I'm here with Maddie and Ann, and we're in, what room are we in here?
We're in the assembly room.
Okay. Looks a little like a party room, too, with all the pizza boxes and things like that. What sort of things do you do in this room?
Well, in the assembly room, we assemble parts for the robot, and sometimes we also do some CAD in here, and we also put a lot of our tools in here, like we have the toolbox here, we have some of our hardware and batteries and a lot of other stuff.
Now, when you say you do the CAD in here, does that mean you have a CAD station that you can roll in here?
Well, we just use laptops for CAD, so we'll bring them from our CAD room to our meeting room, and sometimes even in here, because this is one of our warmest rooms.
Okay. One of your warmest rooms?
Yeah, it gets kind of cold. One of our heaters broke.
I see. You have numerous stations in this room. Do you do different things at each station?
Yeah, we do. So these two are usually used for robot assembly. We have a lot of hardware over there.
Okay.
And then we do electronics right over here. Ann and I were working a lot on that. And then over here we kind of have everything that we just got shipped to us.
Okay. Now, how do you decide if you're going to work on electronics? You just said you and Ann worked on electronics. How do you decide what you work on versus what Hunter works on?
It's personal preference, you know.
Okay.
If you feel like you're interested in electronics, then you work on that.
Okay.
If you feel like you're interested in programming, you work on that, etc.
Okay. Do you find if you have an interest in electronics, do you find that you wind up getting interested in another activity as you watch people do something else?
Yeah. So, Ann, what have you worked on?
Well, besides electronics, I've also done some CAD, and sometimes, like, the reason that I was interested in electronics was just because it was cool to see like all the complicated wires all over the place.
Yeah.
And sometimes in the robot, you need small hands to get in there and do some of the wiring or connecting stuff,
see.
so that was convenient.
I see.
Yeah, and then I got interested for the same reason. It looks really, really cool in my opinion, and I'm also in the mechanical aspects of things. I'm working on one of our arm designs right now to be put on the robot for the next competition.
Arm design.
Yeah, like an arm, as well as an intake, and I worked
Okay.
a bit on grabbing a hatch panel, which is. It's right over there. It's kind of like
Okay.
a big blown up DVD almost.
I see. Interesting. Do you use this as an opportunity to think about what you might do 2, 3, 4 years down the road as you go off on additional studies?
Yeah, definitely. I know I want two things I'm considering are electrical or mechanical engineer.
Okay.
I don't know what I want to be yet, but like being here has definitely impacted like what I consider, like what I've thought about I want to be. Like before I wasn't interested or like I didn't know much about engineering at all, but like after being here, I do want to take like an engineering path in the future.
Yeah. So this has really given you some focus.
Yeah.
I mean, that speaks very highly to the whole program. So, okay. Thank you. Wow, wasn't that something? I am so impressed with the work involved in building this robot. Starting with some dedicated mentors, an idea, and some motivated kids, we see what teamwork can do. Starting with only the rules of the year's competition, a new team, and in 6.5 weeks, an operating robot has been built. 6.5 weeks. So impressive. But this is only part of the story. In the next show, we will see what is involved with programming and operating the robot. We look at some actual competitions among teams. We then take a look at how competitor teams and robots are scouted and how alliances with other teams are built. We then culminate with a look at some actual competition. Look for Littleton Robotics Team 6328 Mechanical Advantage, Part 2.